Hello, in this video we're going to be talking about the insertion sort, what it is, a live demo, the code, and an actual run of the program. So, what an insertion sort is. It's an algorithm which is like the bubble sort, in which the insertion sort compares adjacent elements and swaps them if they're out of order. However, the insertion sort gains some added efficiency by maintaining a sorted list that we insert elements into. Let's see a demo. Here we have 6 cards that we're going to use to demonstrate the insertion sort. We compare the first element to the second element. Our first element is a 7, and our second element is a 2. Since 2 is less than 7, we're going to swap these two numbers. Now we have 2 sorted cards. We compare these 2 sorted cards to our next element. We compare the 8 to the adjacent element to it. Since 8 is bigger than 7, we don't have to swap, because they're in order. We now have 3 sorted elements. We now compare the ace, or the 1, to the 8. Since the 1 is less than 8, we swap. Now we compare the 1 to the 7. Since the 1 is less than 7, we swap again. And since the 1 is less than 2, we swap again. We now have 4 sorted elements. We now compare the 4 to the 8. Since the 4 is less than 8, we swap these 2 elements. Since the 4 is less than 7, we swap these 2 elements. And now the 4 has found its place, because 4 is greater than 2 at this point. We now compare the 6 to the 8. Since the 6 is less than 8, we swap these 2 elements. Since the 6 is less than 7, we swap these 2 elements. And now we have 6 cards in perfect order, thanks to the insertion sort. Now that we have seen a live demonstration, let's start talking about the code. Let's start off with the pseudocode. Here we have our first for loop, which loops over the index of the entry that's to be inserted. And here we have our while loop that's going to perform the insertion. This swap over here is going to swap the inserted element with the adjacent element as long as the item is of lesser value. So let's delve into the actual C++ code. Find my pen. Okay, here's our first for statement where we're going to count the index number, so the item we're looking at. And here's our second for loop, which is going to compare each item, or the item we're looking at, to each of the sorted items. As you can see, j is equal to I, so as long as we've gone through this at least once or at least twice, the sorted elements that the elements that have already been sorted are going to be compared to the element we're currently looking at. If the element we're looking at currently happens to be less than an element adjacent to it, we're going to run this swap, and after the swap is done, it's going to compare it again to the next element, and it's going to keep on doing that until the item can find its place. Otherwise, we're just going to break the loop and continue on to looking at the next element. Now that we've seen the code, let's actually see the program in action. So here's our main CPP file. We're in code blocks right now, and let's just run over the code. Here we have an F stream for our input file and an F stream for our output file. The input file is going to open up random.txt, which is this. And in this file we have 10,000 randomly generated numbers from 1 to 1 billion. We can go to that. And what the output file is going to do is it's going to create a new file in which we're going to dump the sorted numbers. Here we have where we read in the file from random.txt, and in here we're going to push the numbers into an array called iArray. Here's the for loop that we're going to use. Alright, here's the sort, the insertion sort. We've already gone over that. And here's where we're going to print out the sorted array. So let's run the program. It'll take some time because there's other things running in the background. Here we go. It says it took 615 milliseconds, and here is the sorted file. Awesome.